This is our homework assignment for lesson 45, where we're going to control the speed of a motor with a potentiometer. The lesson started out using the transistor, which was an 8050, was rated at 700 milliamps, but that looks like that wasn't the case. Had a real problem with that transistor. It just wanted to overheat, and it seemed like it was drawing down the power supply also. So that resistor or transistor just didn't do the job. So what I did is just put a MOSFET in there, and it was able to handle it. This MOSFET will handle up to 10 amps without a heat sink. But that transistor just didn't handle the rating of what this motor can do. The motor's rated at in the Sunfounder documentation. It says 3 to 6 volts at 0.4 amps, which is 400 milliamps max. It draws a little bit more than that. So let's go ahead with the experiment. It's just a little different. We changed the main player here. We use a MOSFET instead of that transistor. The 8050 that didn't cut the mustard. That one didn't work too well. But anyway, let's get started. So we're going to start it up. Turn the switch just a minute. It comes on. Comes on. And we're going to bring it up. And right now, its power supply shows we're about 540 milliamps just at this speed. I can see why that 8050 was getting hot. I'm going to bring it on up. Five volts on the motor. This is the way it should have ran. We didn't even get full speed with that other transistor. We're going to get full speed with the motor now. You can hear it hum. Okay, the power supply say it's putting out 1.4 amps. So that motor actually is a little bit over that 400 it shows on the data sheet. So we've already over an amp right here. I'm going to back it off. Let's see what the stall current is. I'm going to get it down a little further where I can stop it. At that voltage level, 1.4. All the way up. Let's go back to 5 volts, which is, we're full on. So we actually have a little bit more power. So that's 1.8, almost 2 amps. Back it down. And when we hit all the way to the left here, it should go off about the time we stop. Okay, just bringing it on down all the way. Bring it just up a tad, it should come on. It comes on. That's 550 milliamps right there. So we had two issues. The transistor itself wasn't capable of running this motor, and the power supply, because I think that power supply is only 1.5 amps. Once it started to draw close to an amp, it just pulled the voltage down. So that transistor didn't do the job. But again, all the way down, off. Looking at the code, we have our constants we're declaring for our pot pin, the right pin, and the motor on. This is the speed that we're going to set for our mapping. So we'll map from 102 to 255 on the mapping, and that'll give us range that allow us all the way to the left will be off, and all the way to the right will be full on. And we set up our serial monitor. We're going to take a look at the readouts just for troubleshooting or just to make sure everything's working correctly. We do our analog read of our pot pin. Now we're going to do the mapping. There's two types of linear regressions, or we have the what we call the slope intercept, or B stands for the intercept, where the line crosses the y-axis, or the what they call the point slope form of the line is this equation. This is the slope intercept. As you can look at the way we've written this portion is the slope. This portion is, sense val is the x, and our intercept is b, our motor on speed that we have set at 102. And that gives us the linear regression using that formula. We're going to come down here. We're going to update the read-write values. We have this if statement just to make sure when we do get all the way less than 5, we want to make sure we turn off all the power to the motor, make sure it's actually a 0 right. So anything below 5 will get a 0 right, and that'll make sure that there's actually no power on the motor. Anything above that, we're going to start writing to the motor to speed it up, slow it down. And that's our value right there. That will be the full right. And we go down, we're going to do our serial prints, monitor to the monitor, serial monitor. It looks like next time, it looks like we do have a motor driver in the kit, a TA6586. That should be a little bit better. I think it looks like it's by the data sheet you can get consistent or constant 5 amps out of it. So that should work out a lot better than that transistor did.